Okay, we are live. We're going to talk about solving literal equations. This is a piece, I don't know if I taught this to you last year. And when people first see it, they kind of freak out because it confuses them a little, but it's not confusing, really. But does anybody know what a literal equation is? I mean, literally. What literal means letters, right?
Word problems.
Right. Well, not word problems. Problems with letters in it. In other words, variables, meaning they're all variables, usually. Okay? There might be one or two numbers, but most things are variables. So if I had y is equal to x plus z, okay? Then, and I might say solve for z. Solve for z. When they say solve for z, this is what they want it to say. Z equals. That's what they want it to say. And then whatever z equals is on this side. Okay? Now, we're used to solving for a variable and getting an answer. An answer like z is equal to 2 or -5 or something like that. But in this case, it won't be that kind of an answer because we don't know what any of these variables are. They're numbers, but we don't know what the numbers are. So the answer will be in terms of the variables. But the truth is, you do everything exactly as you would do if they had numbers. You do this, you add, subtract, multiply, divide, whatever you need to do, okay? So, if I was going to solve for z, okay, I just want z on one side of the equal sign and everything else on the other side of the equal sign. Does that make sense?
Yeah.
Right? So what's in the way of z being all by itself?
X.
The x. And is it a positive x or a negative x?
It's a positive X.
Therefore, I'm going to do minus x, and so that would give me y minus x is equal to z. Yes?
Yeah.
Now, it is, if this equals z, then z equals this, right?
Mm-hmm.
So it's totally legal to just switch it. Z is equal to y minus x.
Commutative property.
Yeah. I mean, really, this is really not commutative because maybe it would be considered. Usually the commutative thing is something on the same side, you know what I'm saying?
Oh, yeah.
But regardless, you got the idea, yes.
Is this something new or rewarding?
We may have, you've done some of this in the past, but it's going to feel a little new as I start throwing harder problems on the board.
Alright.
You're going to see, okay? All right, so that's pretty straightforward, right? That was pretty easy. Now, I want to just talk about, before I actually do harder problems, I just want to talk about something. In this case, I didn't really move this, well, let's see, how do I say this? I didn't really move this over. How do I say
You
this?
just flipped it so that.
I just flipped it because I say if z equals this, then z equals the same thing, right? It doesn't matter which side it's on, right? You see what I mean? Right? This is exactly the same thing as this, so it doesn't matter which one I put first and which one I put second between the equal sign on either side of the equation. But if I wanted to move something, notice what happened. This x is positive on the right side of the equal sign. You agree with me?
Mm-hmm.
And notice my final answer was the x on the other side, and it was negative. Do you see that?
Mm-hmm.
Just if you want to move something to the other side, all you have to do is change its sign. Because that's really what you're doing. If it's negative here, you add it, and it's over here now as a positive. Do you follow me? So if I had an equation, 2x plus 3y equals 5z, and I wanted to solve for x, we'll say solve for x, I can subtract 3y from both sides, but I know if I want to move that 3y to the other side, I can. It just has to change signs. Does that make sense? I've got, think about it, if I, well, to do it the long way, I'll subtract, I'm solving for x. I want to get everything else that's in the way of the, it's got to say x equals. For now, we'll say 2x equals. 3y, we're going to subtract 3y, subtract 3y. That gives me 2x is equal to 5z minus 3y, right? Yes? So notice, I could have immediately moved this over and said negative 3y. Do you see what I mean? Because this proves it. Whenever you move a number to another side of an equal sign, it just changes its sign. So you can do that very, very quickly. You know what I mean? But this is showing your work. Now, to get x all by itself, I got to get rid of that 2. I've got to divide everything by 2. And so there's my final answer. X is equal to 5 halves z minus 3 halves y. Does that make sense? It wasn't that hard. The only problem, the thing that's confusing, is that we still have the y's and the z's, right? Normally we would be getting rid of those and we would say, oh, x is equal to 10.
Right, so the problem is already done.
So the problem is done. I was asked to solve for x. That's as far as I can go. You see what I'm saying? Because I don't know what z is and I don't know what y is. Okay? Is it clear so far?
Yeah.
Okay. So now we're going to make it a little harder.
So was that number 1?
This was number 1, this was number 2. Okay, now we'll go to 3. Let's say I said 4x plus 4y is equal to z. And I'm supposed to say solve for y. Doesn't look like 4. 4y. Okay? So I wanted to say y equals. What's in the way of
4x.
Yeah, the 4x is in the way. So I've got to first subtract 4x from both sides. All right? So that gives me 4y is equal to z minus 4x, right? Make sense so far? Now, what do I still have to do?
Divided by 4.
Divide everything by 4. Divide everything by 4. So my final answer is y is equal to, really this is 1/4 z. Do you see the difference? You see how that z over 4 is also 1/4 z. Do you guys see that?
Yeah, no, I got that. Wait, no, I got y equals 1/4 z and minus 1x.
Minus 1x or just x, either one.
Oh.
Right? You could say 1x or you could say x. Right? Does that make sense so far?
Yeah.
Pretty straightforward, right? Okay. I'm doing stuff that are it's almost identical to things that are on the homework, but not exactly, right? So that you have things to look at if you get confused. All right, what if I gave you something like this? A, okay, this is 4. If I gave you A is equal to 1/5 B, C, D. And I said solve
4c.
Solve for C. Okay. All right. So now this is slightly trickier, right? Do you see the fraction?
Yeah.
Immediately when I see a fraction, I don't want the fraction there.
So
I-
you subtract them both sides.
But can I subtract it? What is the fraction doing? Is it multiplying or adding?
Multiplying.
It's multiplying. So I'd have to divide by 1/5, right? But dividing by 1/5, remember in 3rd grade? 1/5 divided by 1/5 is the same as 1/5 copy, dot, flip. You multiply by its reciprocal, right? Remember that? Right? Remember that? So I'm going to technically multiply by its reciprocal, or if I'd rather, remember the trick I showed you last year? If you have a fraction, the only thing that you have to worry about is the denominator, right? I mean, if we multiply both sides by the denominator, I will have no fractions. Do you remember that? Do you remember that?
Yeah.
So if I multiply both sides by 5, this is what happens. That crosses out, and this becomes 5a. So suddenly I have 5a is equal to, looks like 3a. 5a, does that look like a 5?
No, it's real hard to.
5a is equal to bcd. And now I still have to solve for c. What do I do now?
Oh, wait, okay, no shit.
I feel like I should be dancing.
Yeah.
Gary,
Okay,
Gary,
so,
wait, don't you divide B and D?
yeah, because b is multiplying times c, d is multiplying times c. So I could divide both of them at the same time, b and d, right? You see that? The d's cross out, the b's cross out, that leaves c all by itself, right? And I got to put that here, bd here as well. And so my final answer is, I'm going to write this first, c is equal to this, 5a over bd. Yes? It wasn't that hard, right? Once you see it.
It's a process.
It's a process.
There's
It's a
nothing really
process.
like it. Like,
Oh, that's easier. I thought we were going to divide here.
Right. 5. What if I gave you something like this? X squared minus y squared is equal to z squared. And I said solve for y. Okay? Very interesting music in the other classroom, isn't it? Okay, solve for y. So what's in the way of the y being all by itself?
Oh, the X.
The x squared, right? So I'm going to subtract x squared, and I've got negative y squared is equal to z squared minus x squared. You guys agree with me?
Uh-huh.
All right. Now what do I have to do?
add the exponents.
Well, what's no, I can't add the exponents because that's only when you're multiplying, right? And that's when you have same bases. These are not same bases, right? So I can't do anything to combine those. I just could have to write them like that, separate, right? Does that make sense to you guys?
Yeah.
All right. But what do you notice here that's a problem?
It's negative.
Negative. Let's get rid of it, right?
So you, yeah.
So I'm going to multiply the whole equation by negative 1, which is basically going to change every sign in the equation. Does that make sense?
Yeah.
So now that becomes a positive y squared equals, that becomes negative z squared and a plus x squared. Okay? You get
It
it?
doesn't affect the exponent stuff.
No.
It doesn't affect the exponents. It just affects the letter in front, I mean the sign in front of the letter. Okay? Right? Yes.
So we have to turn it into the absolute value?
I didn't do absolute value.
Oh, or you just have to turn it into a positive?
I want, since I'm solving for y, I'm not being asked to solve for negative y. I'm asked to solve for y. So I wanted to say, I want to get it as close to y as possible. Now it says y squared, right? But does that say y? Is that y or is that y squared? Y squared. So how do I turn y squared into y?
Wait, how do you do it?
You can't do it with add, subtract, multiply, and divide, but you could possibly do square roots, right? What's the square root of y squared? If I square root this, right, that would give me y. Because the square root of y times y is y. Remember this? What? Yes? No? You don't?
Yeah, I remember it.
I kind of.
Remember, what is square root? Let's just remember what square root is. Square root of 16 is the same as the square root of 4 times 4. Do you agree with me? You agree with me?
Yes.
When you have square roots, it's saying, technically, I need 2 of the same number for them to come out. Right? So I have 2 4s. That comes out as a 4. So my final answer is 4. Square root of 16 is 4. Does that make sense?
Yeah.
Square root of 81 is square root of 9 times 9. I have two of them. They come out as a 9, so my answer is 9. Right? The square root of x squared is the square root of x times x, right? And I have two of them. So they come out as an x, so my answer is x.
That means
So-
that
So same thing as the square root of y squared is the square root of y times y. It comes out as a y, right? Equals, now what do I have to do? I can't do this. Don't do this. That would be wrong. I have to square root the entire side. So I have to square root the entire side like this. Does that make sense?
So it's negative
So,
z plus x.
Yeah, so it's y is equal to the square root of negative z squared plus x squared, and I cannot go any further. Because I can't, these are not times, right? If that had been negative z squared times x squared, then I could take out a z up here and a x out here, right? But I can't, it's a plus. So that is a blob that I have no idea what it is. I've just got to leave it under the square root sign, okay?
Oh.
With me? So there's going to be a problem like that on the homework. Okay? Okay, so that was 5. What do we have? Got 15 more minutes.
6, right.
And I'm going to do, I might actually do a few that are on the homework. Is that okay with you?
Yeah, that would be fantastic.
Really? Would you really like that?
I love that, Gary.
All right. What if I gave you this? Where are my 5, 6? This isn't yet on the homework. Let me try, well, this is sort of on the homework, but I'll just, how about A over B plus C equals D? Equals, sorry. I don't like to write lowercase, but I have to. D, okay? A over B plus C equals D. And I'm saying solve for B. That one looks confusing, doesn't it?
Yes, it does.
B is in the denominator. How do you solve for B when it's in the denominator? Well, how do you get it? How do you get rid of a denominator?
You multiply it.
By the denominator, right? Oh, by the denominator.
So you do times.
So if I did this times B, I have to multiply everything times B. You see what I mean? Everything's got to be multiplied times B. Everything.
Sounded like a chicken.
So the B's cross out. A plus CB is equal to DB. Yes? You get it?
Yes.
Oh, this makes sense. Because you multiplied
I multiplied everything by the denominator, which was B. Everything. And that's what I got. Now, I notice I'm supposed to solve for B, but B's are on both sides of the, they're on both sides of the equal sign. I can't leave them like that. I have to have them all on the same side, right? Think about if it had said 2B and 4B, right? I would move them to the same side, right? There's side talking again. Minus CB, minus CB. So that gives me A is equal to DB minus CB, okay?
This is
With me?
annoying.
Yes.
I know, this one's harder, right? This one's a little harder. There's one just
Wait,
like this.
but I have a question.
I should have just done the whole.
Wouldn't the B on the right side go away?
What?
Wouldn't the B on the right side go away?
No.
You're subtracting C
Because
from the
if, think of, just whenever you question a thing like that, remember every letter is a number. We just don't know what it is. So you can just substitute numbers in and just see what would happen. If that had been 6B minus 4B, would B's disappear? Or would it be 6 minus 4B, right? 6 minus 4.
Math with letters, because that's real dumb. Albert Einstein.
This is actually really useful.
Yeah, but it's so.
Really useful.
How? Give us an example.
Okay, I'll give you an example. I mean, when
Why is this such a big deal, though?
guys,
I don't get why it's such a big deal.
remember you're supposed to raise your hand. Okay, you gotta remember that. But when years ago, I was hired to be a financial aid officer at Santa Fe. What was that place called again? It's not there anymore. Santa Fe, no, not Santa Fe Community College. College of Santa Fe. College of Santa Fe. I was hired to be a financial aid officer, and they gave me this busy work the first week. They gave me all this data, and I was supposed to, put it into, figure out the can't even remember what the data was, but there was basically an equation like this, and I was supposed to solve for B, right? On everything. And if I left it in this form and plugged everything in, I would have to do all of this messy stuff every single time, and I had to do hundreds of them. And I was thinking, this is stupid. And so I converted it to what we're about to do. And then I just plugged the figures in, and I had the answers almost immediately.
Why can't we do this with numbers though?
Well, that's what I'm saying. You will do it with numbers eventually, but knowing how to manipulate an equation that you're plugging things into is helpful. Does that make sense? Do you see what I'm saying?
Sure.
I mean, I would much rather have my final answer that says B equals something and just plug the stuff into something than have to do this and plug everything in and then suddenly do massive algebra every single time. I'm doing the algebra once. It's a little harder with letters so that it's easier for me when I plug in the data with that equation. Does that make sense? So the last thing we have to do in this one is this. Factoring out the greatest common factor. Do you guys remember this? I don't know if you've done this. A is equal to, I noticed, what do they have in common? They both have B's, so I'm going to factor out a B. And I don't. If you don't know how to do this, then it's just because we haven't gotten there yet. Okay? Do you see what I just did?
Yeah.
I took a B out of this, and that gave me a D. And I took a B out of this, and that gave me a C. It's the reverse of the distributive property, right? I turned this into the distributive property. Does that make sense? Okay, so now I'm solving for B. And B is being multiplied by this blob here, right? So I'm going to just divide by that blob. Divide by that blob. Whoops. And there's my answer. B is equal to this. So B is equal to A over D minus C. Okay?
Whoa. Sorry, my brain is like, my brain forgot what B and D looked like, and I got really confused.
Okay.
It's hard to explain.
This one was confusing.
Oh my god.
This one was confusing. But let's remember what we did. Let's just look at it one more time so that we're clear. We saw fraction. We multiplied everything by the denominator, right? And that immediately got rid of our fraction, which is awesome. We got this. And then we saw we had b's on both sides of the denominator, both sides of the equal sign. So we got them onto the same side by subtracting the CB. And we got them all on the same side. And then we noticed that there was a b in both of these terms.
Oh my god, I get it now.
And so we factored out the b. And that left us just with the d minus c, right?
Yes, I get it.
Okay? And then we realized if we're solving for b, it's just b times this blob. Well, let's just divide everything by that blob, and then b is all by itself, right? You got it?
Mm-hmm.
So suddenly, a over this blob is my answer, right? That would be way easier if I knew that a was 100 and d was 50, and c was 25. I would much rather plug it into this than plug it into this and figure it out. You follow me? Especially if I was given a lot of A, D's, and C's, and I had to, solve for B for all of them, right? It's way easier. It's very, very useful if you get that kind of a project on a job someday, and you might. All right, so let me just look at this really fast. Boom, boom, boom. That's easy. That's easy.
Do we have 5 minutes to do it? Like 5 minutes?
That's easy. Yeah, I'm gonna say don't. I'm gonna just stop the lecture. I'm gonna say you don't have to do 13 and 14. Okay? And you'll see why when you see them. They're hard.